Okay, the last organic compounds to talk about are the amines, amides, and nitriles. These are all different classes of compounds that have nitrogen in them. According to the IB syllabus, though, you don't actually have to name compounds with these functional groups, but you should be able to recognize these functional groups in larger molecules. I think this will be especially important on paper 3 when we do biochem, but it could be on paper 1 or 2 as well. So the different names of the functional groups, amine, carboxyamide, and nitrile. So carboxyamide is because it's sort of like a carboxylic acid, but instead of an OH group, it has this NH2 group. So what are these functional groups? Well, they all involve nitrogen for amines and carboxyamides. Usually we think of it as being an NH2 group for amines and a C to O double bond next to an NH2 group for amides. A nitrile is a bit easier to spot as it's a carbon to nitrogen triple bond. Just in case you end up having to name them, I don't think you could be asked to do it, but I'll show you it anyways. It's ethanamide, ethanamine, ethanamide, and ethane nitrile. So these would be the ones that are 2 carbons long. I realize there's a small error there. So you basically just take the number of carbons and like it would be ethane, you just chop off the E at the end and then you add amine or amide as the functional group ending. For nitrile, you actually don't even chop off the E because it would be too hard to say those 2 N's back to back. So it's just ethane nitrile. These functional groups are always on the number 1 carbon and therefore don't need a number. But I don't think you'll have to name these types of compounds. You just have to identify them. It's useful to note that these functional groups, at least the amines and amides, these hydrogens here can also be they don't have to be hydrogens. These nitrogens could be connected to carbon atoms as well, and the functional group would still be called an amine functional group. Same thing goes here. These could also be carbon atoms, and this would still be called an amide. So the key thing for an amine is just that you've got nitrogen attached to carbon. Key thing for an amide is that you've got nitrogen attached to carbon and it's next to a C to O double bond. So amine, carboxyamide, and that's really what you're looking for, C to N and C to O double bond to N. And nitrile is C to N triple bond. The last thing in the topic is that amines can also be classified like halogenoalkanes or alcohols. It's a little bit simpler with amines in that the nitrogen, you're looking at the nitrogen itself. So a primary amine is attached to 1 carbon and so has 2 H's. Secondary is attached directly to 2 carbons, and tertiary is attached directly to 3 carbons. Okay? The final bit is that you actually have to look at the number of bonds to carbon, not how many carbon atoms there are. For example, this nitrogen atom in adenine, one of the nitrogenous bases of DNA, is connected to 1 carbon here and 1 carbon here in this drawing. However, there are 3 bonds to carbon, 2 to that one and 1 to that one, and therefore this is called a tertiary halogenoalkane because the nitrogen has 3 bonds to carbon. So it's not necessarily the number of carbon atoms it's bonded to, it's the number of bonds to carbon that nitrogen atom has that determines its classification as primary, secondary, or tertiary. Other than that, we can discuss little details in class, but that's a little overview of the nitrogen groups, nitrogen classes of compounds, amine, amide, and nitrile.